Today on My Climate Journey's Startup Series, our guest is Prakash Govindan, COO and co-founder at Gradiant. Gradiant is a Series D stage company that develops technology for industrial wastewater treatment. They work with Fortune 500 clients across a range of industries, including semiconductor fabrication, food and beverage, pharmaceuticals, mining, and more, to help them reuse water in their operations. Prakash and I discuss his background and experiences with water scarcity during his childhood in India. We talk about how he met his co-founder during his doctoral work at MIT, how the company started, and the problem of industrial wastewater today. We talk about some of the different industries and use cases that Gradiant serves, and a bit about how their technology works and how their business model is structured. As Prakash says in the conversation, water is one of the primary interfaces through which the world will experience climate change, whether through drought or flood. And the more we can do to manage our water supply, the better off we will be. But before we start, I'm Cody Sims.
I'm Yin Lu.
And I'm Jason Jacobs. And welcome to My Climate Journey.
This show is a growing body of knowledge focused on climate change and potential solutions.
In this podcast, we traverse disciplines, industries, and opinions to better understand and make sense of the formidable problem of climate change and all the ways people like you and I can help. Prakash, welcome to the show.
Hi, Cody. Thanks for having me.
Prakash, I'm super excited to learn from you today, understand the world of industrial wastewater. And from the reading I've done leading up to our conversation, I really came to appreciate the size and scope of what you do and what you work on, and how it relates to industries I didn't really think of as being large water consumers, like semiconductor fabs, as an example. And clearly, that's an incredibly critical area to be working on from a advancement of technology perspective, from a national security perspective, from where the world is going perspective. So I'm really excited to hear more about your story. Maybe let's start with you giving a personal introduction and how you originally came to found Gradiant.
I grew up in south of India in a city, a metropolis called Chennai. It used to be called Madras. It's the capital of a southern state called Tamil Nadu. And Madras famously has droughts, or infamously. The Indian water situation depends on the monsoon. Tamil Nadu is one of the states which gets the return monsoon, and sometimes it never returns. So there's no rain. So when we grew up, me and my brother, lower middle class, nice household in Chennai, there were a lot of water problems, a lot of droughts. So we didn't get tap water for part of the year. So we would receive water in trucks, in trailers. And so it was our job as the young person in the family to walk down from our house and bring back water in pails, in buckets. So we used to do that twice a week. There was a 4-year period when I was in secondary school and high school. Every week we did this. So very early on, I learned in life the value of water and the value of having tap water. Because what often happens, and one of the reasons that there is this mind-blowing statistic that in the history of water, you invest in startups, you're familiar, there has been only one unicorn. Only one unicorn in the entire history of the water industry, whereas if you take energy storage or photovoltaics or something like that, there's a unicorn every month in the US or other parts of the world. So, and Gradient is that one and only unicorn in the history of the water industry. It's because people don't understand the value of water. Water is not valued correctly. So that's something we are trying to change. But nonetheless, going back to my story, so we used to carry up these pails of water. I learned the value of water. And when I got the opportunity to do my PhD at the Massachusetts Institute of Technology, MIT, I found the water guru at MIT and I became the student and disciple, if you will. John Leonhard V is the water guru at MIT. And during my PhD, we developed technologies which were later on commercialized by Gradiant for recycling and reusing wastewater, industrial wastewater especially, but also applicable outside of industrial wastewater kind of applications. During those 4 or 5 years at MIT, I met Anurag. We were in the same laboratory, the heat transfer laboratory, and we were in the two groups that was working in water. And from very early on, Anurag and I got along really well. We became very close friends. And he transmitted this entrepreneurial bug, this entrepreneurial disease, if you will, to me. He wanted to start a company. And for the better part of 4 years, we kept talking about how we can do that. And it turned out that his aspiration, his mindset, and his nature was very much aligned to running the business side of things of a company. And I'm a very technical person. I consider myself a finite time thermodynamist. We are people who think about entropy and decay and optimizing systems to the extent we lose our hair, as you can see. So it's a nice fit. The two friends with PhDs, practically unemployable anywhere else. And water, the commonality between Anurag and me is also that we never had too much of materialistic aspirations. We didn't want to become billionaires, or we didn't have targets in terms of how much money we wanted to make. Impact was always our goal, honestly, from the bottom of my heart. Water is somewhere we could make an impact. And right at that time in the US, there was this shale oil, shale gas boom. US went from being a net importer of oil to a net exporter of oil and the largest producer of oil at one point in the world in a period of 5 to 6 years during the time we started Gradiant. And this hydraulic fracturing, this unconventional shale gas, shale oil required a lot of water to frack and to deal with the waste also. And Gradient had the ideal solution of recycling 99% of the water within the oil field, making the oil companies water sustainable. So that's where we started. But we diversified into other industries. You mentioned semiconductor. Oftentimes people don't know that an average semiconductor foundry, a fab, consumes 10 million gallons of water a day. Gradient has technology which can recycle 99% of that within the industry. So instead of tapping into outside sources like surface water or river water, the Mississippi River, for example, to run the foundry of the tune of 10 million gallons, they only need 100,000 gallons with Gradient technology. And that was game changing. So we're doing really well in those sectors: semiconductor, food and beverage, mining, oil and gas, and similar sectors. So that's how we got started. Two people out of a lab at MIT. Now we are more than 1,100 people. We have offices in more than 10 countries. And I live in Abu Dhabi.
And you just moved from Singapore. You've been all over the place.
Yes. When we started, we were initially laser focused. We had one technology, one application. But after the first 5-6 years of Gradient, we had built up enough capability and credibility to not only go raise money, to expand into other applications and build a technology platform, a full stack of technologies that can service different industries. But also we had capability to solve local industrial problems around the world. So I moved after first 6 years of Gradient to Singapore, then another 5 years in Singapore. Now I have moved to the Middle East, and as excited as I was on day one.
So I saw on your website for Gradient that you have a couple incredibly powerful statistics. 45% of the world's water is used by industry, and traditionally 70% of that wastewater is then dumped untreated into nature. How is that's mind-boggling. I don't know how much of that number of that 45% includes agriculture relative to some of the heavier industries that you work with. And B, 70% dumped into nature feels like the EPA and other organizations would have regulated that away by now, but clearly that is not the case.
That 70% number is actually quite generous in that it includes highly regulated regions, Europe and Australia, for example. If you take some of the more populated, more where there is a lot of manufacturing and industry, China, India, Asia in general, it's more like 95% of the wastewater is dumped into oceans and rivers and underground water bodies. And the US, especially over the last several years, the EPA has taken a very forgiving stance towards industry polluting water bodies in the US, fortunately. Previously, there was a pretty strict regulations, but recently, maybe 5 years ago or so, it became slightly more forgiving for industry to pollute. So it is a mind-boggling statistics, and kudos on you to look at the website and learn that, but it is very much true. So if you think about climate change, which is the topic of your podcast, climate change almost invariably in all cases first affects society through water, either in the form of too much floods or too little droughts, and securing our water resources. And the reduction in CO2 levels in the atmosphere, I am an optimist. I believe that will happen. Everybody will come together, realize I was at COP28 recently, and I feel optimistic that eventually people will come together and get to minimize CO2 levels in the atmosphere as is required. But it will take time. Consensus, even at COP28, you can see, even though the tagline was climate action, there was very little of that. There was a lot of rhetoric rather than action. So that in that interim time, we have to secure our water bodies. We have to make sure societies have water to survive, if not thrive. And what people don't know, perhaps the common man, is the importance of recycling industrial waste. One, stopping industrial wastewater from being discharged into natural bodies, and two, minimizing the withdrawal of fresh water and potable water by industries. Doing that, how important it is to fill that gap before CO2 is controlled and of the climate crisis. And that's where Gradient comes in, is we close the loop. We have, for the first time in the history of the water industry, Gradient has technology which can take the wastewaters, the toxic streams coming out of these industries, and clean it up to a level where it can be reused within the industry. And for semiconductor, like I said, 99% can be reused. For oil and gas, almost 100% can be reused. It's a big deal. Yeah.
I want to back up a minute to the topic you mentioned, which is, you said in some emerging economies, upwards of 95% of industrial wastewater is dumped into natural bodies of water. And to me, it evokes the question that comes up a lot in the energy context of environmental justice. What is the right of an individual nation state to develop its economy relative to decisions it has to make about its own local environmental tolls? And this comes up a lot in terms of the use of coal, for example, in India and China. Should these countries be required to wean themselves off fossil fuels when what they're trying to do in many cases is catch up to the United States and Europe, which were able to develop on the back of fossil fuels and now are trying to tell the rest of the world, you can't do that? It strikes me that with CO2, it is true, it's a global problem in that the emissions affect everyone. Whereas with water, yes, obviously water is at some limit is a scarce resource, but there is a lot of water. It's just often in the wrong places. Polluting water is more of a local problem than a global problem. Is that a correct way to think about it or not?
Very shrewd observation. The environment, sort of the atmosphere, is so linked. You have the air above UAE, you have the air above America, you have the air above India. The CO2 levels are the same, except for some local air pollution. The atmosphere is very, very linked. The oceans are also linked, but the effect of pollution doesn't transmit. Say, for example, the Yangtze River in China, someone dumps pharmaceutical waste, which contains trace compounds of something fatal. It doesn't affect people living the Mississippi River necessarily. But one thing I really feel about climate change, because of this reason, it starkly brings out the inequalities in the world. There is this island in the Indian Ocean near Australia, which has 11,000 people, and they have lost 90% of their land because of seawater level rising, whereas they hardly contribute to the CO2 in the air. Bangladesh, for example, continues to lose significant amounts of its land and habitat, whereas they hardly contribute to CO2 in the air. So Whereas if you see it per capita, countries like the US or certain European countries or even China, in spite of its larger population, has a significantly higher impact on CO2 going out into the atmosphere every minute, every day. This is where these countries, which are higher emitters, can also invest in water technology and equalize this injustice, if you will, if to use a slightly strong term, because the technology is developed in the US, for example, Gradient's technology is developed in the US and Singapore, can be applied in these situations. We are working on very important projects in that regard in such regions in Bangladesh, for example, where we can help with making sure the water resource is secured for the local community.
I suppose no nation wants to pollute its own populace. They're having to make trade-off choices around development and advancement. Obviously, in some cases, things like corruption and whatnot do come into play. But for the most part, I presume many of these countries that are heavily polluting their watersheds would prefer to not do so. They need alternative technologies to help them prevent it. They haven't developed an economic infrastructure such that they're incentivized against doing it, at least in the near term, unfortunately. I don't know if that's the right way to think about it or not.
It is, Cody. Great examples are China and India. Over the last few years, China has been cleaning up its act in terms of pollution to its water bodies. It has been inviting technology companies to be part of that mix. We partner with them heavily. We have a large grant with one of their city governments, Ningbo, near Shanghai. We are doing a sizable team in China. India is another very good example. India is one of the few countries which has stipulated zero liquid discharge requirements for its industries. It doesn't care whether you build a semiconductor factory which will create 1 million jobs or you are building a small metal workshop. You have to not discharge any water from it. Zero liquid discharge means none of the waste goes out of the factory. And that, whereas there has been desire to do that earlier also in India.
How recent is that in India? That's relatively recent?
Relatively. It was implemented earlier, but technology was the roadblock. The technology, as in it was physically possible to do zero liquid discharge, but you had to boil off so much water. You would be putting so much CO2 emissions in the air and creating another different problem. You're simply moving the water discharge issue to a climate change issue. But whereas with the technologies that are available today through companies like Gradiant, they are able to do that. India is putting down its first semiconductor foundry, and Gradiant is going to do the entire end-to-end water treatment with zero liquid discharge, 100% recycling of all water. So self-sustaining this for the first time in Asia, completely self-sustaining in terms of water.
When I think of water treatment, historically, I think of wastewater, municipal wastewater, sewage. How different are the problems that you face in industrial wastewater from what municipal wastewater treatment facilities deal with?
When we started the company about 6 months in, Anurag gave me a t-shirt. I love that t-shirt. I still have it. I probably put it in the washing machine so many times I can't wear it outside. It's all faded. But I still wear it to bed. Honestly, I love that t. It's one of my favorite t. It says industrial wastewater on the front, and in the back it says variability is the hallmark. And that's so true. Variability, if there is one thing we have learned running Gradiant for the 11 years, it would be that variability is the hallmark of industrial wastewater. Variability in water quality. So on not just a monthly basis, a diurnal basis. In the morning, you would get water which has 5% salt in it and 2% organics in it. And in the evening, from the same pharmaceutical plant, for example, you would get 10% salt and 4% salinity. And when you design separation systems or thermomechanical systems, as an engineer, it's very, very difficult to design for that level of variability. And that's why industrial water treatment, wastewater treatment is much harder than municipal sewage water treatment. Municipal sewage water treatment, the technology has existed for a long period of time. It's only willingness in some parts of the world to invest and maintain and run those facilities. Of course, your previous conversation with the startup There are opportunities to tap into, including extracting valuable things out of that sewage. But that is more value add rather than inherent necessity to do treatment. So industrial water is much harder to treat from a technical perspective and a technology perspective.
Got it. You're referring to the recent episode we published with Cedron Technologies, which folks should go listen to as well if you want to hear more about sewage separation and some of the cutting edge that's happening there.
Hey everyone, I'm Yin, a partner at MCJ Collective, here to take a quick minute to tell you about our MCJ membership community, which was born out of a collective thirst for peer-to-peer learning and doing that goes beyond just listening to the podcast. We started in 2019 and have grown to thousands of members globally. Each week, we're inspired by people who join with different backgrounds and points of view. What we all share is a deep curiosity to learn and a bias to action around ways to accelerate solutions to climate change. Some awesome initiatives have come out of the community. A number of founding teams have met, several nonprofits have been established, and a bunch of hiring has been done. Many early-stage investments have been made, as well as ongoing events and programming, like monthly Women in Climate meetups, idea jam sessions for early-stage founders, climate book club, art workshops, and more. Whether you've been in the climate space for a while or just embarking on your journey, having a community to support you is important. If you want to learn more, head over to mcjcollective.com and click on the Members tab at the top. Thanks, and enjoy the rest of the show.
Let's talk a bit about some of the use cases that Gradiant solves. You've touched on a little bit semiconductor fabrication. You've touched on a little bit pharmaceutical. I know you do things in food and ag. You do things in precious metal extraction. You obviously got your start, as you mentioned, in the oil field. Maybe share a bit about the primary use cases and some of the differences inherent therein.
The pharmaceutical example is something I love, right? When I first moved to Singapore, this very responsible, one of my favorite clients, a Fortune 100 pharmaceutical company, came to us and said, we have this problem. Our wastewater has this thing. The local utility, Public Utility Board, PUB of Singapore, one of the best utility boards in the world, by the way, they are saying they will fine us if we continue to discharge this into their sewer.
I think I saw the use case on this in an article. Was this GSK, specifically around amoxicillin and penicillin waste? Is this the use case you're hinting at?
Yes. So none of the other water companies could offer a solution. And they were at their wits' end. So Gradiant went in, we took the wastewater, we tested. So we are a bespoke solution provider. We have 250 patents, we have 10 commercialized technologies, but we are not a technology company. Our business model and our service model to the customer is not that we sell a widget or we license a technology or anything. We do the end-to-end solution for them. So we develop using our existing technologies, but with other pre-treatment and post-treatment, which is more off the shelf. We developed the end-to-end solution for this client. And for the first time in Singapore, we did a zero liquid discharge system for this amoxicillin production facility, completely eliminating their problem and minimizing energy and CO2 emissions at the same time. That's a test case we are really proud of. The semiconductor example, like you mentioned, we service large semiconductor clients around the world who, on the one hand, they require 10 million gallons a day of water, and not just any water, Cody. Semiconductor industry is unique here because they make these chips of very small feature sizes. We are talking nanometers. And the water is the solvent often, which flows over during certain processes, this semiconductor material. So it cannot contain any contaminants which will interfere with the features that they are producing. So they require ultra pure water. We are talking not parts per billion, not parts per trillion, parts per quadrillion level purity. So 1 in 10 raised to 16, for 10 raised to 16 parts of water, 1 part of contaminant can exist. That level of purity. But at the same time, when this ultra pure water comes in contact with the different chemicals and substrates in the process of producing the microchip, it produces different kinds of toxic wastewater. And this is the unique challenge. Whereas in pharmaceutical, the unique challenge is the nature of operations, for example, one of the unique challenges. What I mean is, an amoxicillin production facility, for example, is operated in batches. There will be a batch of a certain drug they will produce for a period of time, and then a batch of another drug related but another drug that they produce at a different point of time. They do this in a way to minimize their operational costs from their perspective, but each of these batches has vastly different wastewaters coming to the plant. So, as the solution provider for the water treatment piece, you have to be able to handle these vastly different wastewaters. So, whereas that is the challenge in pharmaceutical, the challenge in semiconductor is there are often 15 types of wastewater that comes at you. You can't just mix them and co-mingle them and treat them as one. You need to provide specific solutions to several of them. And to have that breadth of technology, expertise, and know-how, very few companies in the world can do it. And of all of those, sorry to toot my own horn, but Gradiant is the only one at this point which can recover 99% of the water and still do all of the water treatment. That technology edge. We have also been very successful with mining applications. Mining consumes a lot of water. There are two aspects of it. One is extraction of valuable resources from brines. For example, lithium. Salars have become a major way of extracting lithium from Mother Earth.
This is DLE, or direct lithium extraction, I think is what I hear the industry talk about.
Yes, direct lithium extraction and the subsequent production of lithium carbonate or lithium hydroxide in the process. So Gradient's technologies, typically within that extraction process for lithium, evaporate some of that water off because, above a certain concentration, you cannot use membranes. So let me, if you don't mind for a minute, get slightly technical.
Please. That was going to be my next line of questioning was how does this all work? So dive in for us, please.
So, if you have a saline water, it can be seawater, it can be lithium saline brine, and you're trying to extract fresh water out of it and in turn concentrate some of it. You typically use this reverse osmosis technique, which is it's a non-porous semi-permeable membrane in that it allows by osmosis through it water, but it doesn't allow any salt. In order for the water to go in the right direction from the saline stream to the fresh stream, you have to overcome something called the osmotic pressure. This osmotic pressure exists because there is salt in the water. So you overcome that by reverse osmosis. You apply pressure on the water and fresh water goes through the membrane. This is an amazing technique. This has been perfected over the last 40 years. So seawater desal, for example, every drop of water that I drink, my family drinks, anybody drinks in the UAE is desalinated water. UAE doesn't have any rivers. Saudi Arabia has no rivers. For a country with a population of 30 million people, zero rivers, Cody. Just imagine that. And they subsist primarily by seawater desalination. They take seawater, they extract fresh water through it primarily by this reverse osmosis process. Before reverse osmosis was developed, they were using techniques which would be based on evaporation. They would apply heat, they would evaporate water and condense it. Highly energy intensive, very high carbon footprint. But it has been phased out by reverse osmosis. The limit of this reverse osmosis process, though, is you can go to only a certain level of salinity. If you take the seawater in the Gulf here, or the Indian Ocean or the Pacific Ocean, the average seawater of the world is around 3.5% salinity. You can concentrate that 50%. And which means if I take 100 liters of water and I pre-treat it and I send it to a reverse osmosis or RO membrane, I can produce 50 liters of fresh water and 50 liters of concentrated. Above that salinity, the osmotic pressure goes exponential. It becomes asymptotic to the abscissa that you cannot extract any more fresh water economically out of it. So what they typically do, for example, for lithium extraction application, you have to produce solid from the brine. You have to produce lithium hydroxide, lithium carbonate from the brine. Without increasing the salinity to those levels, you cannot. So the initial extraction is done using reverse osmosis or RO, and the later extraction typically was done using evaporation. And that is a problem because you require enormous amounts of thermal energy to do it. Carbon footprint, availability of thermal energy in remote locations, somewhere in Australia or somewhere in Argentina.
These are these big brine pools that you see pictures of? Is that what we're talking about here, or is that something different?
They were trying to do brine pools also, but then you're reliant on the precipitation, and with climate change, the precipitation patterns are constantly changing, and it's a mess. What Gradient has been able to achieve is expand in a paradigm shift way the applicability window of RO. We have this technology called counterflow reverse osmosis.
RO being reverse osmosis.
Yes, CFRO being counterflow reverse osmosis, we are able to expand the applicability of RO, and using patented, clever ways, we are able to, for the first time in the water industry, concentrate these waters all the way up to saturation of salt, just using membranes, no evaporation, no thermal energy input. So that is a game changer for the mining industry.
It sounds like it's also a game changer from a water desalination perspective, though I haven't heard you talk about that much on any of your positioning, which is interesting.
Seawater desal is an interesting market for Gradient, but not every seawater desal plant in the world requires a zero liquid discharge because the ocean is so big. You can take water and typically concentrate it and put the rest back into the ocean, but there is a penalty. At COP28, I was on 4 or 5 panels. One of those panels with global lawmakers and regulators in the mix on the panel, we discussed just like a carbon credit, a brine credit. If a company minimizes putting brine into the ocean, because putting brine into the ocean has multiple effects. We think of the ocean as infinite. It is very big, but it's not infinite. Eventually, the amount of water being desalinated today, the amount of water being projected to be desalinated in the near future, the overall salinity of the water is going to go up. And even before that happens, locally, the marine life is significantly affected sometimes. I'm not an expert on marine biology, but if you talk to environmentalists, for example, this is one of their opposition. For example, there was going in Huntington Beach, California, there was going to be a large seawater desalination plant. They spent tens of millions of dollars, if not hundreds, to do all the work to set that up, but the permit never came through. It was canned because of this specific concern. Applications like those, Gradient can go in. In applications in Saudi Arabia, we are already doing that. Go in using CFRO. We can reduce and minimize the amount of brine coming through. We can even produce salt from that seawater, extract not just common salt, but we can extract other kinds of minerals from that seawater. So you're spot on. That's an application for our technology.
Super helpful. Sounds like an application, but not necessarily a primary focus. Whereas lithium and other metal extraction sounds like is a primary business line for you today.
Yes. In an ideal world, if I had infinite bandwidth, I would go after seawater desal right away. As a company that is, albeit growing at tremendously fast rates, I still don't have the bandwidth to go everywhere simultaneously. So I'm picking and choosing the most impactful things we can do.
Another area that I saw you work on is a topic that, frankly, I think probably doesn't get enough attention, which is this topic of PFAS, or forever chemicals, these chemicals that you can explain them probably better than me, but that essentially cause permanent contamination challenges. Maybe explain a little bit about the problems that you deal with there.
Great point. Perfluoroalkyl substances, PFAS and PFOS, and related compounds, they're rightly called forever chemicals. They don't degrade with time, and they are put into the environment initially by the invention of 3M, the non-stick coatings, and even in your non-stick pots and pans in your house have these, and they go into the water, they go into the air.
This is like Teflon. Is that what we're talking about here?
And a whole bunch of associated compounds, not just Teflon, but Teflon is definitely one of them. So recently it has been shown that PFAS and PFOS is extremely bad for human beings. In adults, it can cause heart disease, cancer, etc. In children, it can be fatal at high concentrations. And recent study was done in the US, the heartbreaking results. 50 wombs of mothers was tested, and something like 80% of them had PFOS in the womb. So in water is a big problem. It's not yet regulated by the EPA. They're still trying to figure out what is the right level of contamination that can be allowed.
I'm just thinking about it in my own life. I've had nonstick pans. That stuff is just clearly chipping off around the edges, which sounds horrible.
Yeah, and it doesn't degrade, Cody. It just stays in you. You then give it to the next generation. You give it to the next generation. Where that will end is the scary thought. There's a movie on this. I forgot what the movie is called. Deep Water, something like that. Nice movie. In any case, whereas the entire industry is trying to minimize the problem and then sweep it under the carpet, what Gradient has achieved via its technology in PFAS is we are able to destroy the compound. So we will concentrate it using, I have been saying, if more than a water treatment company, Gradient should be known as a water concentration company. That's our expertise. That's where we have invested our R&D. So that piece we are really good at. We concentrate the PFAS up. And then we have technology now, which we built from scratch in our lab to destroy it. Using an electrochemical technique, we can destroy the PFAS, which means the problem is eliminated. The technology is not yet commercial. It's still in pilot testing phase, but we hope to get it out there soon because it's a solution that the world requires. And it's not just PFAS, Cody. It's not just PFAS and PFOS or this for our chemical. There are emerging contaminants from every industry that is not being regulated today. You take pharmaceutical industry, there are long chain compounds that come out of production of, for example, birth control pills. And those are difficult to destroy. The typical water treatment plants don't catch them and they get discharged into the sewer. There was a case recently where we were contacted by the Chinese government because a pharmaceutical company and its water treatment partner, a Singaporean company, I don't want to name them, they allowed discharge of a trace compound into the Yangtze River. And this compound is not yet regulated, but has known health effects. So this emerging contaminant area is very much something I'm also personally focused on from an R&D perspective because it has a huge impact on the world. We are constantly inventing new ways to make products. Industries are constantly changing solvents and ingredients and so on. And the effects of some of that going into the wastewater is often not studied up front. It behooves companies like Gradiant, who are water treatment experts, to sort of focus on this.
Looking at the list of customers that work with you on your website, it's some really big names. We've talked about semiconductors. It's folks like TSMC. It's folks like Micron. We've talked about pharma. It's folks like GSK and Pfizer. Talked about mining. It's folks like BHP, Rio Tinto, food and bev, Coca-Cola, AB InBev, right? These are some of the world's largest brands, chemicals, DuPont. What does it look like when they work with you? You said they are paying you to solve this problem end to end. What's the actual operational setup and what is the financial mechanism that they're using to work with Gradiant?
It varies. I'll give you the example of our semiconductor clients in the US. The CHIPS Act was passed, which is a great thing, honestly, for the US and for the industry. And within the CHIPS Act, they stipulated that those who are getting this funding, the semiconductor companies, have to meet certain water sustainability standards, water recycling standards, including zero liquid discharge. Perhaps for the first time in the US, that's been stipulated. So that is driving some of this. And operationally, how that looks is we are typically Gradient is the end-to-end solution provider for water. So they will come up with an RFQ. This is what we need, black box. They will invite companies to bid, and Gradiant gets involved at an early stage because we can advise companies on what their problem is, which in some cases is difficult to put a finger on for non-water experts, because let's face it, semiconductor people are semiconductor experts, not water experts. So we get involved with the RFQ, and then the RFQ comes out, and then we come up with a design and we bid. And once we get the order, we go in and not only do we design, build, and deploy the end-to-end system. These are large-scale water treatment plants that we build. We also tend to operate them for a period of time for customers. And this is where our AI technology is so useful. We are one of the very few handful of companies which can not only supply the technology and the hardware for water treatment, but also the software and the AI optimization piece which minimizes carbon footprint, which minimizes energy consumption. We operate the plants. Sometimes, Cody, we even find investors and we own the plants. So it's build, own, and operate. It varies from industry to industry. The GSK example that you said, they typically like to own their assets. So we sold the plant to them and they are excellent operators. So we train their operators. They run the plant themselves. So industry to industry, country to country, we are flexible. We say we are here to solve your problem, not to create new ones. So we don't want to put any limits on how we will work with you.
These plants are typically co-located at the manufacturing facility, presumably, so they're catching water because you're not just treating the waste. And like you said, in most cases, you're actually recycling it back into their operations so that they're not having to continually source new water.
Every case we are recycling almost every case we take the wastewater and we give it back to them. We are typically within the chip foundry, within this pharmaceutical plant, within the food and beverage plant. We are in there. So we have to comply to their safety standards. For someone with a PhD and a scientific background and an entrepreneurial bent, this was a learning, over a period of time, because you quoted our list of clients from the Chevrons of the world to the Microns, the global foundries. Because we work across such a diverse group of high-end clients, our safety mechanisms are cutting edge and they apply. Then I have 500-page long safety trainings that every one of our employees have to take because we have to comply to semiconductor and food and beverage and pharma and everything else.
When you extract a valuable byproduct from waste, are these clients wanting to get into your ability to monetize said byproduct if that's not part of their current business line?
In some cases, yes. Textile is a great example. In order for dyeing operations to work, in order for this to be dyed the gradient purple color, I'm a little colorblind, I think it's purple. You have to put salt in the water along with the dye. So this is typically Glover salt or calcium sulfate decahydrate. It costs 10 times that of common salt. What Gradient is able to do is, in India, it was a problem earlier that some of these dyeing operations was discharging the water into the sewer.
We've all seen horrible pictures. Yeah, for sure.
But what Gradiant does is not only eliminate that disposal and not only eliminate their sourcing problem, because in a place, for example, in South India, there's a city called Tirupur, which is a textile city. There are so many textile mills, dyeing mills there, that they say the ground is filled with dye in that part of the world instead of soil. But what Gradient does is make sure that these mills don't have to take water from the local bodies in addition to discharge. But also the third thing we do in those applications is what you mentioned earlier. We produce Glover salt of a quality that can be reused from the wastewater. Same is true there are nickel mines we work for in Australia, for example, where we are able to increase the recovery of nickel from the incoming source of nickel. So typically, say 60% of nickel is recovered. We are able to increase the recovery by another 20% because of our water treatment operations. In the case of textile, they will let you share in revenues when you produce that. Because others are not able to do that, and Gradient is they will share in revenues, whereas in the case of mining, it's more of a conversation.
I mean, it's their core business. It makes sense that they might already know how to monetize that byproduct.
Very interestingly, we had proposed at one point that we will produce road salt because in Texas and in the US, in winter, you need road salt to avoid icing of the roads. We'll produce road salt from oil and gas, wastewater, produced water. We couldn't get the permit from the local authorities because they said anything coming out of the oil field is oil field waste. So even if you produce a clean product out of it, you cannot use it in. So typically it has to be used within the industry. Otherwise, regulators have a problem with it.
You have recently, I guess now mid-2023, announced your Series D round of funding. It was a $225 million round of funding. As you have mentioned, valued the business north of $1 billion. Congratulations. And something over $400 million raised to date into the company in general. I noticed most of your investors are large family offices, PE, et cetera. It doesn't look like you went the route of traditional venture capital in the early stages. I'm curious if you can describe what the early days of funding Gradiant were like and how that has changed as you've grown.
Anurag and I are, I would say, somewhat unlike typical, perhaps you guys come up against Silicon Valley entrepreneurs. We are engineers. The ability of our venture capital friends, especially back in the day when we were still raw out of MIT, to understand what we were trying to do and put a value on this water treatment company. We talked to plenty of VCs, but we gravitated naturally towards high net worth individuals and family offices, all with ties to MIT. That ecosystem around MIT is amazing. And honestly, Anurag is amazing at fundraising. If it was just me, we would have raised $0.
You have a serious business. I think I saw, I don't know how recent the stat was, but it was $200 million or so in revenue, I think, give or take. I don't know what you're able to disclose. I saw that somewhere on a website or something.
More than 200 million in revenue this year and 500 million in backlog. We have $500 million in projects already signed. So we will easily do north of 350 million the coming year. And sky is the limit. Honestly, we believe we will break the $1 billion in revenue mark over the next 3 years. And already, even though we only raised Series D early last year, it's been only a year since we raised Series D. If we go out and raise money at any point now, we'll get valued at multiple billion, not just one, because of this success.
There are not a lot of companies like yours, but I'm going to ask this anyway. A lot of companies like yours, heavy infrastructure companies, over the last few years went public via the SPAC route. You obviously chose to not do that. I'm curious how you all contemplated that pathway while it was open. It's not necessarily open anymore, but while it was open, and the decision to not go that route.
The option to become a public company is there, and it was there through the SPAC route. There were so many SPACs that approached us, and we had some serious discussions with a couple of them. But we felt it was never for Gradiant. Keeping it private, we have access to a lot of capital. Our current investors, even if we don't add a single new investor, our current investors have very, very deep pockets. We don't need to go elsewhere. And keeping it private, while Anurag and I never aspired for large wealth and never continue to be the same way, for us, running the company and making sure it has impact, there's an effect. You can see in many startups, when the entrepreneurs leave, the nature of the company changes. It becomes more just P&L and less about the impact on society and so on. We don't want that to happen. And naturally, when it goes public, I think Anurag and I become misfits in the company. So one of the reasons we didn't take the SPAC route, you saw how the SPAC thing is turning out. A lot of those companies which listed at insane valuations are now trading a tenth the price or something. That's another thing which would have limited the impact of Gradiant on the world. I mean, we couldn't digest that a SPAC offered us, $7-8 billion in value. That was 3 years ago when we were less than 100 million in sales. It just doesn't make sense. I mean, you see the pattern, right? No VCs, no SPACs. We are normal people.
I have one other question for you. We talked about it before the show, though I didn't get the answer, which is the name of the company. Every time I type Gradiant, spell check tries to add an E instead of an A. So you said there was a story there that I want to hear the answer to.
I think this answer will reveal that I'm a total nerd. I was obsessed during my PhD, and I continue to be so, about driving forces. What drives people, what drives nature's forces, and fundamental driving forces behind water treatment, especially desalination, is at the local level in membranes, at the local level in evaporator tubes and whatnot. It is gradients of concentration and gradients of temperature. And mathematically, a gradient of concentration is written as delta N, and mathematically gradient of temperature is written as delta T. And a cross gradient of concentration and temperature is where Gradiant as a company thrives. That's what we have broken in terms of the science. So that is delta NT. So it's actually not an A, it's GRADI delta NT. But then but Anurag and others told me you can't put a delta in the name, just make it A. So it became Gradient with the A.
That's amazing. Prakash, I so appreciate your time with us today. Is there anything else I should have asked or anything else that you want to make sure we know about? And also, if there are areas where you need help or support from any of our listeners in any way who are inspired by your story today, certainly feel free to share that as well.
Absolutely. First of all, thank you. Very, very insightful questions. You have done so much research. I often do these interviews, not so much podcasts, but to have an interviewer so researched and informed is a pleasure. There is nothing that we use, no products that we come in touch with, which is not impacted by water. So to your listeners, whether they are in the carbon capture industry or power sector or whatever they might be in, if there is a water problem we can help with, reach out to Gradient with the A. We're happy to be of service. Thank you for your time, Cody, and thank you for this insightful questions and interview.
Prakash, thank you so much. I've really enjoyed it.
Thanks again for joining us on the My Climate Journey podcast.
At MCJ Collective, we're all about powering collective innovation for climate solutions by breaking down silos and unleashing problem-solving capacity.
If you'd like to learn more about MCJ Collective, visit us at mcjcollective.com. And if you have a guest suggestion, let us know that via Twitter at MCJPod.
For weekly climate op-eds, jobs, community events, and investment announcements from our MCJ venture funds, be sure to subscribe to our newsletter on our website.
Thanks, and see you next episode.